Bismillahirrahmanirrahim. Welcome back, my dear students. My name is Abid Rida Babil, and today I will teach you the quantum number again, but in a different way. We will not go behind the definitions and the information of the quantum number, but we will just do the calculation, how to calculate the quantum numbers and how to calculate the number of electrons and the orbitals in the subshell. This is the main objective of our today's class. So let's go to our lesson. Here I told you there are 4 quantum numbers. The first quantum number is n. First quantum number is n. So n can be equal to, that is principal quantum number, n can be equal to 1, 2, 3, 4, 5, 6 and 7. The alphabets for this shells or the principal quantum number is K, L, M, N, O, P, Q. So in principal quantum number there are 7 shells, because in the periodic table there are 7 periods. So there is no formula, no calculation, just these are the numbers, whole numbers, no zero, start from 1 and finish at 7. These are the 7 principal quantum numbers. This represents the 7 shells, and because there are 7 periods in the periodic table. On this basis we will start the calculations also. So if n is equal to 1, though n is equal to 1 here, so it means it is K shell. Similarly, it could be n is equal to 2, and then we can say n is equal to 3, and here we will learn about n is equal to 4. Okay. Second quantum number is angular momentum quantum number, and it is represented by L. The formula, here we have formula. In principle we don't have formula, but in the angular momentum quantum number we have formula. It starts from 0 and goes to 1 before the n, finishes at 1 before the n. This is the rule, this formula. So L can be equal to, it could be 0, it could be 1, 2 and 3 and so on. If it is 0, it will be the subshell. We write here subshell. This 0 will be equal to S, this 1 will be equal to P, and this 2 will be equal to P, and this 3 will be equal to F, SPDF. And let me write here shells, because this for principal quantum number, this represents the shells. Shell is equal to KLM and OPQ, and here subshell will be equal to SPDF. So you see here, if n is equal to 1, then L is equal to 0 and finish at 0, because 1 before the n means we cannot go to the 1 here, it finishes at 0. And then we say here ML, magnetic quantum number, which I am going to teach you now. This will be also equal to 0, and this represents the subshell S, this S. Okay. So here if we say L is equal to start from 0 and 1 finish, not 2, because we have to stop 1 before the n, so we cannot write 2 here, it will be stop at 1. And then for this n is equal to 3, so L will be equal to 0 1 and 2, not 3, because L starts 1 before the N. And here, if N is equal to 4, L will be equal to 0, 1, 2 and 3, not 4, okay. Now come to the next quantum number rule, that is magnetic quantum number ML. ML will start from minus L and pass through 0 and finishes at plus L. So this is the rule for magnetic quantum number 3, magnetic quantum number. So we finish here, ML is equal to 0 because L is equal to 0, ML will be also equal to 0. No need to write, this is just simply S orbital. In the K shell, when N is equal to 1, there is only one orbital, that is S. Very simple. But when the shell number 2, that is L shell, N is equal to 2, L will be equal to 0 and 1, not 2. And the ML for this, if this is 0, this will be also 0, and it is S orbital actually, okay. And this L is equal to 1, then ML will be equal to minus 1, 0 and plus 1. So the meaning here, these are 3 orientation. These are the quantum numbers for this subshell. And inside this subshell there are 3 orbitals. These 3 orbitals, minus 1, 0 and plus 1. And the name are Px, Py and Pz. So orbitals here will be equal to 3. And electron will be double of it, 6 electrons. Okay, and here also we'll complete the orbital is equal to 1 and electrons will be equal to 2. And now you come here, when the M shell, principal quantum number 3, L will be equal to 0, 1 and 2, not 3. So ML will be equal to, similarly here, if L is equal to 0, ML also 0, it means S orbital. And when L is equal to 1, this will be equal to minus 1, 0 and plus 1. Same, this is Px, Py, Pz, Px, Py and Pz we already did here. These are 3 orbitals, but the new thing is here is ML will be equal to minus 2, minus 1, 0, plus 1 and plus 2. So these are the 5 orbitals. So let me write the name for it, but you do not need to remember it. dxy, dxz, dyz, dx square minus y square and dz square. These donut shapes, 5 d orbitals. Actual thing is that you have to remember it here. These are how many orbitals? These are 5 orbitals, and these are here 3 orbitals. So here we say the orbitals numbers are 5, and then electrons will be equal to 10. Now come here, this one, if L is equal to 0, then similarly ML will be also equal to 0, and this will be minus 1, 0 and plus 1. This will be equal to minus 2, minus 1, 0, plus 1 and plus 2. This is the new thing here. when L is equal to 3, then ML will be equal to minus 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3. We don't have the names here or the shape because highly complicated, but only to know that these are 7 orbitals. So we write here orbitals is equal to 7 and electrons is equal to 14. So this was a detail. Now let's come back again here to finish this fourth quantum number. This quantum number 1, principal quantum number, angular momentum quantum number and magnetic quantum number. The fourth one is ms. Again, no rule like principal quantum number. It have only 2 values, plus half and minus half, clockwise and anti-clockwise. No formula, no rule, just you have to remember that 2 numbers are there that represent clockwise and anti-clockwise spin of the electron. So each electron here, one will have plus half and minus half. So let me draw here. For this will be 1 plus half and 1 will be minus half. Similarly here also in the px, you can draw this px here like this in the box. It represents the orbital. So one will be plus half, another will be minus half. Similarly this is also same thing. Py also 1 plus half and another is minus half. Plus half and minus. So similarly it will go for all like this. Each orbital will have 2 electrons. So what is the next summary we have? There's some detail about this L. Let me elaborate this angular momentum quantum number again to write the number of these orbitals and the electron in the table here. So again we see this L is equal to, if L is equal to 0, it can be equal to 1, 2 or 3. Okay. So 0 means this subshell. So 0 is equal to S, 1 is equal to P, 2 is equal to D and 3 is equal to F subshell, SPDF. Now orbitals here, one orbital, and this we calculate this 3 will come here. In the P there are 3 orbitals. In the D these are 5 orbitals. So D we can say these are 5 orbitals. F we have 14 orbitals here. So F is 7 orbital, and the number of electrons will be double, 2, 6, 10 and 14. So this is the just a summary of angular momentum quantum number, because it have the formula, it have some naming SPDF, and it have some details that how many orbitals and how many electrons. So the other thing is that I told you when it is n is given and it is they are asking the number of electrons, then it is 2n square. This will give you the calculation for the electron, and simply just you say n square, then it will be equal to number of orbitals for the shells for the principal quantum number. Okay. The other rule is that if you want to calculate the number of electrons in the subshell, then formula will be electrons in the subshell 2L plus 1. So answer will be, if you calculate by this rule, same answer will come this one. This will come 2, 6, 10, 14. This is electron, and for the orbital, here in the same subshell, orbital, it will be equal to 2l plus 1. So answer will be 1357. And we have by a calculation here we have done this, and if we want to use these rules also possible in the problems directly by this rules you can calculate, and when they ask you the details of the name and number of orbital and electron, then you have to answer like this. So this is the complete detail of the calculations of the quantum numbers and the orbitals and the number of electron by the detailed calculation and by the formulas. Both answers will be same, 1357 and 2, 6, 10, 14. So I hope you understand this and it will be helpful for you. Okay.